Okay, so we're going to move on to another context, common context with derivatives, which is straight line motion, right? So we're going to be talking about position. And then we're going to be talking about the derivative of the position function, which is velocity. The rate of change of the position is the velocity, and then the rate of change of the velocity is the acceleration. So you guys probably remember all this stuff from physics. Now we're just going to attach the derivatives to it. So if the position function is f of x, right, then we know that the velocity function is going to be the rate of change of that, or f prime of x. And then if we need the acceleration, the rate of change of the velocity, it's going to be f double prime of x, right? Things we've done before. So we're going to talk a little bit about what all this means when you put it together. And I'm going to be honest, the straight line motion is another one of my not so favorite topics. Maybe it's because physics wasn't my favorite class, and it reminds me of that. So the first thing we're going to talk about is velocity. So velocity, when an object moves, its position changes over time. So we can say that the velocity function, v of t, is the change of a position of function over time, which is just the derivative, right? So here they used some different notations for the functions, but v of t is a derivative of the position function s of t, so s prime of t. So if we're talking about horizontal or vertical motion, right, if the velocity is greater than 0, that means the object is moving to the right. If the velocity is less than 0, that means the object is moving to the left, right? And if the velocity is 0, the object is not moving. And the same can be true when you're talking about a vertical line. It's just up and down instead of left and right. Sometimes people confuse speed with velocity. Remember, speed doesn't indicate direction. Speed is just how fast it's going. It's the absolute value of velocity. And then let's talk about acceleration, right? So acceleration is the change in velocity over time. It's the rate of change of velocity. So it is the second derivative of the position function, or the first derivative of the velocity function. So just some things to note about that, right? If you're talking about a horizontal line again, if the acceleration is greater than 0, the object is accelerating to the right. If it's less than 0, it's accelerating to the left. And then again, if it's at 0, that means the velocity is not changing. There's no change in velocity. No change in distance over time. And then same thing true for vertical line. You just talk about up and down. So then you put these two things together, right? Velocity and acceleration, and we're going to figure out, does that mean this thing is speeding up, or is this thing slowing down? So let's think about this. Here we are. Let me just open up this other tab. Okay, so for the first one, if the velocity, let's go across, okay? So if the velocity is greater than 0, if the velocity is greater than 0 and the acceleration is also greater than 0, we know that this particle or this thing is speeding up. It's going faster, right? Because they're both increasing. What if the velocity is increasing, but the acceleration is less than 0, the acceleration is negative? We know that thing is slowing down, right? It's slowing down. Okay, what about if the velocity is greater than 0, but the acceleration isn't changing? I'm saying the acceleration is equal to 0, right? That means that the rate of change of the velocity isn't changing, so that the speed here, this is a constant speed. There's no change happening, right? So we know that's going to be true here too, right? Because it doesn't matter that the velocity is negative, it's still going to be a constant speed. Okay, now let's go through this one. Go through the second row, those other two. If the velocity is less than 0, well, we know the object is moving towards the left, but then also the acceleration is greater than 0. So that thing is slowing down. Slowing down, right? Why? Because if we go back up, if the acceleration is greater than 0, that means it's accelerating to the right, but the velocity is less than 0, so it's moving towards the left. So those two things put together mean it's slowing down. They're counteracting each other, right? Or this opposite is true here. This is speeding up. They're both negative, so it's speeding up. All right, so what does it mean if the velocity is equal to 0? So let's come back up here. If the velocity is equal to 0, the object is stopped. It's not moving, okay? So now let's take that and add it to the idea of the acceleration being greater than 0, right? So, but does it matter? No, because the velocity equaling 0 means that the thing is stopped, right? If I come back up here and look at this table, the object is stopped. So it doesn't really matter what's happening to the acceleration. The particle is stopped. And stopped. I'm going to find here we are, my 5 commandments. So using that information, I'm going to give you the 5 commandments of particle motion. So things that you can kind of review, make sure they make sense. We have them in the tables above, but it'll help you kind of use these in your justifications to FRQs. So if the velocity, it changes here. If velocity is positive, we know the particle is moving right. And we're going to talk about left and right motion in this. And then if the velocity is negative, the particle is moving left, not mowing. And then the speed, remember, which is the absolute value of velocity, the speed is increasing when the velocity and acceleration have the same sign. If we go back up to our table, that's true, right? When the velocity was positive and the acceleration was positive, it's speeding up. When the velocity is negative and the acceleration is negative, it's speeding up. So if that's true, the opposite is also true. The speed is decreasing when the velocity and acceleration have opposite signs. So we can look at our table and see that's true. When the velocity is positive but the acceleration is negative, the thing is slowing down. When the velocity is negative and the acceleration is positive, the thing is also slowing down. And then the last one, which is talking about when velocity is equal to 0. The velocity equals 0, but the acceleration does not equal 0. Then the particle is momentarily stopped, which we wrote in our table. But we didn't add this, that it's changing direction, right? That change, that acceleration is showing a change in direction. So let's use these commandments to solve some problems. We're going to start with one on a table. Did I do this one? I think I did. Yeah, here we are. Well, I started with the first one anyway, so I'll work through the second one with you. So there's 2 functions here, position functions, okay? And they're traveling in a straight line. So let's deal with A first. So here's the position function. So if I need to, I'm going to use this to plot the velocity function. And we're going to use the velocity and the acceleration function to talk about whether the particle is speeding up or slowing down. So let's start by finding the velocity. I'm just going to put it up here. The velocity function is a derivative of the acceleration, or sorry, of the position function, which means that is equal to 2t minus 6, right? That's a derivative of that function. So now let's think about it. When is the velocity going to be 0? The velocity will be 0 when t equals 3. So at t equals 0, at t equals 3, I'm going to write a 0. I'm going to do a different color. I'm going to label this v of t. Okay, so that thing is 0 when t equals 3. So what happens to the left of 3 seconds? So if t is 0, 1, or 2, we know that the velocity is going to be less than 0. So in this section, we can write, well, I'll just type it here. I'm going to type it underneath here. when t is less than 3, we can check and see that v of t is also going to be less than 0. So what I'm going to do is I'm just going to come in here and put some negative signs to show that it's negative. Okay, and then we know that the opposite is true here, that when t is greater than 3, v of t is greater than 0. The velocity is greater than 0 if I plug in a number that's greater than 3. So I'm going to come over here and label the side of 3 with positives. Okay, so we're trying to check if this thing is slowing down or speeding up. So we need to check the sign of the acceleration as well, because remember, for it to speed up, the signs of acceleration and velocity have to be the same. So let's label this a of t. Now let's find a of t. A of t is a derivative of the velocity function, v prime of t, which is the second derivative of the position function. So what is the derivative of the velocity function? Well, that's just 2, right? I'm taking the derivative of 2t minus 6. That's just 2. So the acceleration is always 2. So I can come back over here and I can label this thing. This thing is always positive. Doesn't matter where you are. Acceleration is positive. So where is this thing speeding up and slowing down? Let's write here. So let's do where the signs are the same. So between 3 and infinity, right? I'm just going to type it. The particle is speeding up because a of t and v of t are greater than 0. So we can say are both positive. Underneath. And then when is this thing decreasing? Well, it's decreasing when the signs are different. So that's from negative infinity to 3. The particle is slowing down because a of t is greater than 0 or positive, right? And v of t is less than 0. Okay, so let's do the same thing over here. If you want, you can pause and do this when you're on your own and see if you get the same answer as me. So I'm going to label this v of t. I'm going to label this one a of t. Okay, the derivative of this function up here is going to be 3t squared minus 6t. And then I'm going to go ahead and find the acceleration function here, which is the derivative of that one. That's going to be 6t minus 6. Okay, so I found those derivatives. Now, when is the velocity going to be 0? When it's going to be 0 when that function is equal to 0, which is at t equals 0 and t equals 2. So let me type that here. The velocity is 0 there, and the velocity is 0 there, right? So I didn't solve that equation, but you can do that and check, right? When I plug in 0 or I plug in 2, I get 0. Okay, so now let's look at the signs. Let's pick a number over here and plug it in. If I plug in -1, right? So that would be 3 times 1 is 3, minus 6 times -1, that's positive. So over here, the function is positive. What about if I plug in 1? Well, that's going to end up being 3 times 1, which is 3, minus 6. That's negative. And then what happens if we pick a number greater than 2? Let's pick 3. 3 times 3 squared is 9. 9 minus 6 times 3, that's positive. Right? So I'm just doing a little sign chart here. Okay, now let's do the same for acceleration. Let's pick a number. Well, let's find out where this thing is 0. So 6t equals 6. So acceleration is 0 at when the time is at 1. So let's pick a number left of 1. Let's pick 0. 6 times 0 is 0. Minus 6 is negative. So this is negative. Now what if I plug in 2? 6 times 2 is 12. 12 minus 6 gives me a positive number. So now I'm going to use these sign charts to help me figure out when it's slowing down and when it's speeding up. So is there a place where the signs are the same? I notice that both the velocity and the acceleration are positive when t is greater than 2. Right? So it's speeding up. It's speeding up when the signs are the same. I'm going to go back up and check this, right? So here's our chart. So we're looking for when it's speeding up. So when they're both positive or when they're both negative. This just isn't the answer I got before, but I wrote the wrong thing. So when are they both the same? They're both the same when from 2 to infinity, right? Particle is speeding up because both v of t and a of t are positive. Okay? And then we can also see that it's negative here. So actually, if we look at this, what I'm going to do is I'm going to draw a line. So they're both negative here to here, right? And then actually, they're both positive from, yeah. So we can see that this little area here, they're both also negative, right? And this area here, from 2 to infinity, they were both positive. So we have one more thing we can write in here. Let me select this. And from 0 to 1, the particle speeding up. Actually, I'm going to add it here. I'm just going to kind of write the opposite, right? V of t and a of t are negative. And then when is it slowing down? Well, it's slowing down when the signs are not the same, which would be from negative infinity to 0 and from 1 to 2, right? So we can write that down here. I'm going to try to squeeze it in. Get a new text box. And we'll say, let's make this one black. From negative infinity to 0. And from 1 to 2, the particle is slowing down because I'm just going to generically say because v of t and a of t have opposite signs. I was trying to think if might consider writing them out differently for each one, but I'm just running out of space. So I didn't want to take up too much of it. Okay, we have one more. I know this video is getting long. So this one is from the AP exam 2012. So you can pause and come back and check and see how you did, or you can just stay with me. Where is this? You know what I'm actually going to do to make this video a little slower or not so long? I think I might. Well, it's not too long. I was trying to see how long this one is because I want to slow this video down. Instead of babbling, I'll just solve it. So for the time being between 0 and 12, a particle moves along an x-axis, so a horizontal axis. The velocity of the particle is given by this function. The particle is at position x equals -2 when time equals 0. So part A says, for the time given, when is the particle moving to the left? Well, we know the particle is moving to the left when the velocity is negative, right? So we need to figure out when this function is negative. So to do that, let's first find out when v of t is 0. So when is v of t equal to 0? I'm going to mark this here. This is A. I can write my A correctly. So if I look at the v of t function up there, it's cosine pi over 6t. So when is that going to be function? Or when is that going to be 0? So we need to really figure out when cosine, and I'll write theta, is 0, right? Where is the cosine function 0? Let's find that. Well, if you pull up your unit circle or Google one really quickly, or you've memorized this from last year, you know that cosine function is 0 at pi over 2 and 3 pi over 2. Okay? So we need to figure out what t has to be so that when you multiply it by pi over 6, you get one of those two numbers, right? So we are going to set up, it's going to take me a while to write all the ones I have. Pi over 6 times t equals pi over 2. And when does pi over 6 times t equal 3 pi over 2, right? We have to solve both of those equations. So I'm going to set them up and let's solve it. So when is this thing going to be pi over 2? Well, it's going to be pi over 2 when t is 3 because you'd have 3 over 6, which is a half. So this is when t equals 3. And to get 3 pi over 2, that would be the same as times 3 times, it would be 9 pi over 6. So this would be true when not t is 9. Okay. Oops, and my t didn't show up here. Okay, so now I know that my velocity function is 0. So I'm going to label this v of t. So we know it's 0 at 3, and we know it's 0 at 9. So we need to figure out when it is negative, right? So you can plug it in and check, right? Or you can think about it. So if I plugged in 0, let's say, for t, and I got cosine of 0, well, what's the cosine of 0? That's positive. Okay, now let's pick another number here. Let's pick 4, right? Because that will work nicely, I think. Now let's pick 6, because if I pick 6, I'll end up with 6 pi over 6. So cosine of 6 pi over 6 is just cosine of pi. And what is cosine of pi? What's negative? And then I can come and pick one over here. I could pick 12, right? And I would end up with 12 pi over 6, which is 2 pi. So that's positive again. So based on my sign chart, for part A, when I had to find out when the particle is moving to the left or when the particle is negative, I'm going to come over in here and say the particle is moving to the left when t is between 3 and 9, because v of t is less than 0 on this interval. All right, there's part A. So now let's look, we skip part B from this FRQ because we don't know how to do it yet. So part C says, to find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. So the first thing we need to do is find the acceleration. So, oh, not B, C. Okay, so we need to find the derivative. B prime of t is going to equal A of t. Okay, so let's find the derivative of that function. So I'm going to come over here. We're going to write A of t equals, well, the derivative of the cosine function is negative sine of all that stuff that's in there, right? We're going to have to use the chain rule, pi over 6t, pi over 6 times t. And then the derivative of the inner function. So what's the derivative of pi over 6t? Well, that's pi over 6. Okay, so there's my derivative. And it asks us to find the acceleration at 4. So if I plug in 4, I end up with negative pi over 6, right? And sine, I'm just putting the pi over 6 over in the front. And then I'd end up with 4 pi over 6. Okay, I'm going to change my color. 4 pi over 6, that's just 2 pi over 3. So we need to remember what's the value of sine at 2 pi over 3. And that is root 3 over 2. And it's still being multiplied by negative pi over 6. So when I multiply that out, I end up with negative root 3 pi over 12. Okay, so I know my acceleration is negative when t equals 4. So now if they're asking us about speed, I also need to find the velocity at 4. So let's find the velocity at 4. Let's use the function up there. It ends up being cosine of what? That's going to be 4 pi over 6. We already know 4 pi over 6 is 2 pi over 3. What is cosine of 2 pi over 3? That's just 1/2. So this is cosine of 1. I'm sorry, this is cosine of 2 pi over 3, which ends up just being negative 1/2. Okay, so the sine of the acceleration function is negative. The sine of the velocity function is negative at t equals 4. So that means this thing is speeding up. So I'm going to come over here and write my justification. At t equals 4, the speed is increasing because the velocity and acceleration are both negative. Okay, this video is getting long. I'm going to pause it. I'm going to stop it. I'll see you guys later. Bye.